In this video, we deal with a little calculus related to e and the natural log. The derivative of something like this, which has an e function in it, is e to the jx. I'm going to put that I out front. And then we need to multiply by the derivative of the power. So I'm going to multiply by that j, kind of like that. You can see it's written out in words here. In general, when you take the derivative of something that has e in it, you recopy the whole thing and then multiply it by the derivative of the power of e. So you can see that's what I've done here. I've recopied the whole thing. Boom, there it is. I times e to the jx, I times e to the jx, and then you multiply that by the derivative of the power. Let's try that for this example. If we take the derivative of this, which I'll label as f prime of x, you recopy the whole thing, negative 6e to the 3x. And then you multiply that by the derivative of the power, which is 3. Stick a 3 out here. Then if we simplify that, I'm getting negative 18e to the 3x. See, that's not so bad. Let's try the next one. We take the derivative of this, we recopy the whole thing, e to the 4x. And then we multiply by the derivative of the power on e, which is 4. That's it, right there. 4e to the 4x. That's how you do that. What about if we want to take antiderivatives or integrals of e? It's similar. What you do is you recopy the whole thing, just like before, k times e to the lx. But instead of multiplying by the derivative of the power of e, you divide by it. So I'll just put that in front like that. And that's put here in words. We recopy the whole function and then divide it by the derivative of the power of e. So let's try an example or two here. If we want to integrate this, we're going to recopy the whole thing. 8e to the 2x. But now we divide by the derivative, which is 2. This simplifies to 4e to the 2x. Let's try another one. If we want to integrate this, we're going to recopy the whole thing, negative 4e to the 12x, and then we need to divide by the derivative of the power, which is 12. So if we simplify this, I think we're going to get negative 1/3 e to the 12x. Just for fun, let's differentiate this last one and see if we're okay. Remember, when we differentiate things with e in it, we rewrite the whole function. Let me do that. And then we multiply by the derivative of the power on e. So I now have to multiply by 12. What does that give us? Negative 4e to the 12x. Look at that. Boom, right there. See? Negative 4e to the 12x. There you go. What about natural logarithms? The derivative of the natural log, we're not going to prove this to you. I'm just going to say 1 over x, or sometimes x to the minus 1. That's the derivative of the natural log of x. If we want to integrate 1 over x, this is going to come into play. If we want to integrate 1 over x, we get log of x. If you want to differentiate log of x, you get 1 over x. So we will see that. We're not going to have to integrate in this class natural log functions, so that's kind of nice. Here's a helpful statement that my very first calculus teacher at the University of Illinois, Urbana-Champaign said this in class, and I wrote it down in my notes, and I've never forgotten it. The derivative of the natural log of something is the derivative of the something over the something. Right. So if we take the derivative of this, f prime x, the derivative of the natural log of something is the derivative of the something. So let's do that. Let's differentiate that. Wouldn't we get 6x squared? And that's it in the numerator. The derivative of the something over the something. Beautiful. The derivative of the natural log of something is the derivative of the something over the something. Let's try one more here. What would this be? The derivative of the natural log of something is the derivative of the something. Let's see. What's the derivative of sine x? Cosine x. The derivative of the natural log of something is the derivative of the something over the something. Cosine over sine. What is that? Cotangent? Cotangent x. There you go. That's as much as we'll have to do in this class with e and natural logarithms.